complex numbers, examples 11 and 12. In example 11, we're asked to find the modulus and argument of 4 plus 3i. Now, if you just draw yourself a quick diagram, 4 along, 3 up. So that's the sort of thing we're looking at. And this would be the argument measured from the horizontal x-axis, if you like, from the real axis. So the argument of z, which we express, the modulus of z, which we express with two vertical lines, is just the length of this side. And I'm going to use my knowledge of Pythagoras to just write down that the answer is 5. 4 squared, add 3 squared, square rooted. So 3, 4, 5 triangle. Now for the argument, we want to find this angle here, so we're going to do inverse tan of 3/4. Make sure your calculator is set in radians. And when you do that, it's not a standard angle, it's not one of the ones that we recognise. It works out to be 0.644. Just check you can get that on your calculator. I tend to give them to 3 significant figures if it doesn't say otherwise. So modulus is 5, argument is 0.644. If we look at example 12, this is a little bit more complicated. Draw yourself a little diagram of what that looks like to start off with. I think the argument's going to be a little bit more difficult to work out. So minus 3 is here, and then minus 2i. So this is the complex number that we're looking at here. So it was 3 along that side. Don't put minus 3, the minus just indicates direction. The actual length of the side of the triangle is 2 and 3, so don't put the minuses in. That just indicates it's to the left and down. Now the actual argument, remember, is always measured from here. So what we're actually going to be looking for is this angle here. So we'll come back to that in a second. Let's just focus on this triangle. I'll call that theta in there. So the modulus is going to be the square root of 3 squared plus 2 squared, and I'll leave that as a third, that's root 13. For the argument, well, theta, we're going to have to work out first, is the inverse tan of 2/3. And that works out to be 0.588. Keep the full value in your calculator because we're going to do a little extra step now, aren't we? Now that's the size of this part here, but we want this part. Now, if that was 30 degrees, you'd be telling me that this is 150 degrees. You'd subtract it from 180. Well, when we're working in radians, 180 is pi, so I'm going to have to do pi minus 0.588 to tell me the size of this part in radians. So it's 180, equivalent of, minus whatever your angle is. So if you work that out, I think that works out to be 2.554. And that looks like we've finished, but 2.554 is positive, and that means it would be up here. And we are not up there, we're under here. That means it's a negative argument. So the argument of this complex number z is actually minus 2.554. Another thing to look out for is we want an answer between pi and minus pi. So if you get an answer that's bigger than 3.14 or less than minus 3.14, you've probably made a mistake somewhere, so you need to check that.